I'm back on the Leak Delta 75 receiver. If you remember from the previous video, I wasn't all that thrilled with the build quality. This one we found we had a shorted driver transistor. I've removed, because again, here's another thing that just kind of annoyed me was the way they built this. So just to refresh your memory, let's take a look at how I came to the conclusion that this transistor was failed by looking at some scenes from the previous video. Since the fuses are blown, I'm also concerned that maybe we may have some output problems. So let's just check the output transistors and see whether there's any shorts on these outputs. Oh yes, that's not a good sign. That transistor is shorted. That one measures good that direction. What about the base to emitter? The base to emitter is okay. Definitely this transistor is shorted. Here it's shorted emitter. Is it emitter to collector? Well, base to collector. We'll disconnect the base and see whether it's the transistor that's shorted or whether it's something that's further back. That might not be a transistor. It might be a driver that's further back that threw the transistor into full saturation and blew the fuse. So that's why I disconnected. It's shorting base to collector. We'll see if that base to collector short went away with removing the wire, which it did. So now we measure the transistor. It's an NPN, right? There we go. That transistor is good, but it's the short to the wire that drives it. So interesting. Let's go back further in the circuit, find where that short is. Something is shorting to the collector, and what that would have done, or to the base, what that would have done is that would have thrown the transistor into full conduction, which would have immediately sent a DC voltage to the speakers and popped that fuse. So here's the wire that I disconnected here, the green wire here. Okay, this green wire, when I put my meter on that green wire, as you'll see, between the collector and that green wire, I have a dead short. But my transistor, it's an NPN, so if I go between the collector and the base, it just beeps once. 0.5 volt drop between the emitter and the base. It's good. Between the emitter and collector, we're not beeping. So we have a short somewhere ahead of this transistor. It's on this green wire, which goes on this multi-connector, which goes, looks like it goes underneath the unit here. It does. It goes down to this board here. Now, which one is it though? There's two of them. It goes onto this driver board. Let's see which one it is. It's one of the green ones, so let's go to the green wire here, because one of these is going to be one channel and one's going to be the other. Looks like it's that one. Okay, so our short is on this line here. This is where these things start to become fun to work on. I mean, it's not a good design. The transistor right here, it's a driver transistor. Let's just check that and just see if it's shorted. I bet it is. Looks like it's right here. Yeah, that looks like that one's shorted. That transistor here looks to be shorted. Although if you look at this, oh, this is just a joke. Look at the done down here. This is the transistor down here. They got a resistor. They got just, you know, it's like the resistor is an afterthought. Let's just, you know, mount the resistor in where the transistor base is supposed to go, and or whatever lead this one is. I can't tell from the basing here of it, but I just soldered the lead on, and I've done the same thing on the other one down here. Okay, let's see if I can get that transistor out of the board anyway. There we go, it's out. And we'll take it off this resistor here. Ouch! That's hot. Okay, here's the transistor that I just removed. We'll now measure it out of the circuit. It's shot. This one we found we had a shorted driver transistor. I've removed, because again, here's another thing that just kind of annoyed me was the way they built this. The only way to get at the board to work on it is actually to remove the wires, and then you can kind of bend the board out of the way here so we can look at the placement of the parts. The driver transistor that failed was right down here, and weigh it down there to hold it down. As you can see how they attach the transistors. Well, here's the other channel. We've got a PNP, an NPN, a PNP, and an NPN. And you notice here they just kind of stood a resistor up on end to connect it to the base, which again is kind of, you know, they could have probably done a little better job than that for if you had to modify it after the fact. Anyway, beside the point, the transistor that it used was, what was it? Was it MPS U06, I believe it was? Anyway, I got the schematic for it too. You want to talk about a joke? There's the schematic. This is the service manual. I've got the entire service manual. Okay, here's our output transistors. No problem there. Showing our 4 output transistors. But you notice that the driver board itself is just listed as a driver ass. We have no schematic. All these boards on this unit, they don't publish the schematics for them. They just show it as an entire unit, as if you're supposed to replace that entire board if anything's failed. That's okay. You can draw your own conclusions there as to what I think about that. I have exactly the same opinion for when Sony did exactly that for the power supply for the SLV-R5, which they also did, where they just said, here's the power block. When it breaks, you replace the entire block. Great. What happens when the power block's not available? What do you do then? Throw it out? Anyway, transistor that failed on there is not available as an original replacement. I found a 2SC1628, which may work. I'm not sure yet. It's got a similar specification. That's what we're going to do in this video. I'm going to put the transistor in here and see whether we can get this thing working, and then see if I can get it back working in stereo, because somebody has modified this unit to make it work with both speakers driven off the same channel, which I discovered when I plugged headphones in. Anyway, getting the soldering iron warmed up, we're going to mount this transistor in on the board here and see what happens. Now, because I don't have any basing information, there's nothing mounted, nothing on the board to indicate which is the emitter, which is the collector, which is the base. I think it's pretty easy to figure out which one the base is. That'll be the one in the middle that's going to the resistor. But I don't know whether the original transistor was emitter-based collector or a collector-based emitter. Usually they're emitter-based collector, is usually the way that they were configured. So I'm going to measure here. The collector is normally connected right to one of the tabs. So this one here is a collector. So this is emitter-based collector. So now we need to measure the other good transistor that we know to know which side is the collector. Otherwise, I could end up putting the transistor in backwards. So we know that the other transistor is this one down here because it had the resistor. Also, these are the MPS U06. These are U56, which are the PNP transistors. So if I put my probe on the tab, which will be connected to the collector, I'll be able to measure which side is actually the collector. And in this case, it's this one. So yeah, if I do measure it on the top side here, you'll see that the basing is the same. It's emitter-based collector. There's our lead there. Okay, emitter-based collector. So this transistor goes in the same way that the other one came out. Collector. So this one's going to go in just like that, because this is our collector side right here. So that transistor is going to go in just like this. We're going to take the base lead We're going to bend the base lead up to connect to the resistor. And we're going to mount the transistor in the board just like that. I'm just going to clear off some solder here so I can mount it in place. Okay, transistor is now connected. Now we can go about and put the board back in place and reconnect the wires. And now we've got our wires to reconnect over here. Now I did mark them on the board as to which colors came off where. We had a gray and a black wire both going down to this terminal here. I don't like that. It almost looks like that is bridged. Just going to clean this up a bit. It looks like there's a bit of a bridge here at the back, and I don't know whether it's supposed to be there or not. So I'm just going to clean this up. Make sure that we don't have a short. But it does look like PC board material. So our gray and our black go onto the same terminal. That's how they were connected, so I have to assume that that's correct. But then again, somebody else did modify this unit before, so. And we have our blue wire was over here, our violet here, and our yellow over here. So our blue wire, connect our violet first. Violet goes over to here. Yellow wire over to this side. And our blue wire over here. Not too happy with the solder on this one, so I'm just going to reflow it a bit. See this piece of wire that was cut off there. It was. Okay, that's the wires reconnected the way they were when I got it. Now let's put a fuse in it and see if it works. I got the transistor mounted, got the boards remounted in here, and I'm going to try this out now with headphones. Plug it in and turn on the power. Well, I hear stereo sound. Okay, we have sound. It actually sounds pretty good. Let's hook up some speakers and listen to it through some speakers. Okay, got speakers hooked up to it now. It's working in stereo. Let me get some royalty-free stuff on here so that I can actually play it, because that's just playing off the radio, and I really don't want to pull a copyright hit for that. So let me just find patch cord, and we'll plug in the portable DAT machine. That way I can put some royalty-free stuff on, and then you guys can listen to it for a few minutes. I have both channels working now, and I'm actually getting stereo sound, whereas before, the way it was wired up, I was getting sound out of both speakers, but it was only the right channel that was coming through both speakers. And when I plugged the headphones in, that's when I clued in that I only had one channel, because the fuse was blown for the other channel because we had a short on the driver transistor, which was pulling this transistor here into full saturation, which blew the fuse. Okay, now I've hooked it up to tape input, and I've also modified the tape inputs on this, and I'll show you some shots from the first video that I did, because well, you'll see stuff cut in anyway, because as you saw earlier in the video, I cut in some shots of the actual troubleshooting just so that this is a complete video, because I did the first video and the client at that point hadn't decided whether he wanted to spend any money on it, and then he had a change of heart and decided he wanted to spend it. So I went and got some parts and got it going, and he was complaining that the tape level input was much lower when he plugged it into a CD player, and I found there was a couple of resistors in line with the input control, or the input jacks, which were removed. Well, after I speak to the client, he was telling me that yeah, he did try the tape inputs and everything was low, that the signal was low, and I was looking at this and it looked like they might have some resistors on the leads here. So let's just take a look and see. There's certainly something under these green tubes that go to the auxiliary or the tape input. Look at this, we have a resistor. We'll take that out. I'm going to hook these up directly, because that would certainly explain why the level is lower, and it is lower. When I just listened to it, and it definitely is lower than it is when it's plugged into the auxiliary. So I'm going to remove these resistors here and wire them up directly. A closer look at that resistor is brown, black, yellow, which would make it 100K. So that is going to really lower the input for sure. Let's remove this 100K resistor. We'll do the same thing for the other one on the other side here. Just cut it out of the way here. This was probably set up with resistors on the inputs, because this was probably meant to plug into a tape recorder that had external speaker plugs on it and not line level plugs. Oops, that didn't stick very well, did it? That's the only reason I can see for having 100K resistors on the auxiliary input is they're padding that for a reason. Probably because when this was built, people were plugging tape recorders in that had a much higher output than line level. So we'll get full volume out of this thing. Well, we will if I can get my Variac to start working again. My Variac's cutting out on me. Oh, I can hear my Variac is sizzling away. I gotta get a new Variac. Can you hear it? My Variac is on its last legs. It likes to not put out power sometimes. Okay. We should have some music playing here. When my DAT machine decides it's going to go, play. There we go. These aren't the best speakers in the world, but they're good enough. If I put it in mono, it actually goes to mono. You know, it's too bad the input, the tuner for FM, AM, and long wave knob was missing. They say that's how it came in, as it came in with that. So it's on FM now. And this knob here had been broken before and it had been glued in place, so it fell off on me and I put it back on. But this knob is missing. It'd be nice if they had that knob, because the unit's actually not in bad shape. There are a few scratches on it. Now that I got it working, I can actually glue down that back, the heat vent on the back, the brushed aluminum bezel on it that the glue has come off, because we now have a piece that will go back into a collection of fine old equipment. Maybe not the best built piece of the era, but you know what? It's not bad. It's not a lot of power, but I know someone's going to ask me this, so I got the output portion of the schematic, which is really the only schematic that they give you. They just give you the left channel, and the right channel is identical to this. Anyway, the output transistors on this, they're all NPN. There's 4 of them. It's what's called a quasi-complementary output, and how it's done, this was quite common by a number of the manufacturers in the 1970s, and the reason why it was done was because PNP transistors of the day, high output current PNP transistors, were rare and relatively expensive. They had figured out how to make good high power NPN transistors, but PNP transistors were pretty much limited to small signal transistors. You have to remember, back in the early 1970s, germanium was still used for a lot of transistors, and most germanium transistors were PNP type. The silicon transistors were NPN, but they hadn't developed high current, high power PNP transistors that they could produce in quantities at low cost. So a very common way of doing it was what was called the quasi-complementary, and this is exactly that. If we look at the schematic here, you'll see, and this again is only one channel, but here's our drivers, right? These are our driver transistors. These are actually on the board that I repaired. You have a PNP and an NPN, and in the case of what blew here, it was the NPN transistor that blew. They drive the pair of NPN outputs, but your speakers are actually coupled with a capacitor. So that's what these bad boys are right here. These are actually the speaker coupling capacitors. If we clip the scope on here, we'll actually see they're not filter capacitors as some might assume. This amplifier actually only has a single supply, which is that big capacitor there. That big boy is all the voltage for everything. If we look at these, output capacitors, we'll see that if we look on the scope, we'll see that we actually have. Watch my tape be done there. Probably have to rewind my tape now. I think there's only 4 or 5 songs. Okay, we'll see audio here. So that is that's the audio output capacitors here that go right to the speakers. You just saw that lights flicker there. That would be my Variac. Watch what happens when I touch it. The power will come back on. My Variac is on its last legs. I think I've overloaded this one just a few times too many. What do you think? It's got a burn spot on the transformer there that if I set it to that voltage, which is that's 120 volts, if I set it there, it starts to really act up. So it caused my DAT machine to shut off because it's plugged into it as well. And this is, of course, plugged into the isolation transformer. That light bulb is still loose. I have to fix that up. Hey, it works. It's in stereo. Client is thrilled that this piece is now working again. Going to put it back together, and we're going to glue the front bezel back on it and make this thing look like $1 million. So now I'm going to stick on the back bezel that's come off on this thing. I'm going to use some double-sided tape. I think this will probably hold this thing in place as good as anything else. Maybe not. It's sticking to the wood after all, so I don't know how well it'll stick to wood, but it might stick. This might stick okay. And if not, well, we can always put some glue on it. But I have some double-sided, really strong double-sided tape here, so this might just hold this back bezel in place just fine. There you go. The back piece is held in place now. We'll connect up the speakers last time here and just do a final test before sending it out. So here's our speakers. Yes, that's normal because it is a capacitor output, so there was a bit of a charge on the output speaker, on the output terminals there. Power on, and we'll give it our stupid thing. Time for a new variant. I was at the electronic shop today. I should have bought one when I was there. Oh well, it'll give me an excuse to go back and get another one. Right and left channel plugged in. Unit turned on. And I'm on tape input. And there's the two speakers. Stereo sound. There you go. Hope you enjoyed this video. Now I'll get all the people that were screaming at me for not fixing it last time off my back. Yep, another fine old piece that's kept out of the landfill. Real wood too, right? None of this veneer crap. This is actual real wood. Could use a bit of refinishing on it, but other than that, you know, other than the fact that it's got a missing knob here, it's actually not in bad shape. Catch you in the next video. Bye for now.